We're going to talk about computer organization. Basically, you're interested in data. And you can think of a spreadsheet like Excel as giving you a way to manipulate data. So data could be a quantity that you could store in a cell of a spreadsheet. And in a way, the cell actually is a metaphor or an abstraction of a physical location in your computer where the data actually resides. So we want to step back a little and look at the computer and what happens when you're working on a spreadsheet or another program. So first of all, let's talk about the parts of a computer. And there's usually a few basic parts, the things you choose when you're buying a new computer. So first of all, there's a processor. And sometimes this is called the chip. It's where the work gets done. Typical brands are like Intel or AMD. So they're companies that specialize in building these chips. Modern chips often have multiple processors on one chip, actually. So sometimes these are called cores. And the advantage is if you have, say, 4 cores on a chip, they can work together as a team to get your work done. So the computer can be faster. Often there's also another processor, usually on a separate chip or even a separate card, that basically deals with the graphics. So a lot of times you see the chip described in terms of its speed, which will be measured in something like gigahertz, and the bigger that number is, the faster the processor is, and therefore the better. Okay, now inside the computer there's a working memory, and this memory is like the memory on your microwave. Now if you've ever had a power failure and you look at the time on your microwave clock, it'll be going like 12, 12, 12 because the power failed and it forgot what the time was. The same thing happens when you turn your computer off. Everything that's in this working memory gets forgotten. This working memory also has a speed measured in megahertz, the bigger the better, and it has a size. And again, the bigger the size, the better, because say you have a bunch of large programs opened at the same time, well, the more that can be in the working memory that the computer can get access to quickly, the better. Because the good thing about this memory is it's very fast, and it's connected closely to the chip so that the speed of the computer getting things from that memory is much faster than from the other kind of memory, which we're going to call storage. Now this is also sometimes called the disk or the hard drive, though sometimes it's made up of the same kind of devices that you use in a flash drive, so it's doesn't have to be disk shaped at all, really. The good thing about this storage is it remembers, it holds its value when the power is off, but it's much slower than working memory. And you want a lot of this. Typically in a new computer you're going to get several gigabytes worth. And that way you can store a lot of things that take up a lot of space, like pictures and videos and music. Okay, there's sometimes a special kind of memory that mediates between the processor and the working memory, and that's called the cache. And this is special, very fast memory. By having this, the computer can actually stage the data into the cache, and so make it even quicker for the processor to get that data when it needs it. All right, we also have a bunch of input devices. Typically, you're going to have something like a keyboard, a mouse, a microphone, a camera, probably. You can also have game controllers. Your computer can be hooked up to a laboratory instrument, a sensor, something in a car. Just, there's a ton of possibilities. And there's also tons of potential output devices. Usually you have a screen and a speaker, but you could also have a robot arm or a car's brake system and tons of other things, whatever you can imagine. Now, what makes a computer as opposed to some kind of smart device like a car or a TV or a washing machine is that the program is actually stored in the memory just like the data. So your computer isn't limited to one kind of program. It can accept and execute new programs. If there's an update to the operating system, you can download it and have a new and better operating system without taking your computer back to the shop. And potentially a computer can even modify its own programs as it works, and this is how computer learning can take place. Now, that's a pretty sophisticated kind of application, but it is potentially available. Now, everything in the computer, every kind of data, every kind of program, every kind of picture, every kind of music, everything is stored in the form of bits. It's stored digitally. And that means it's stored in tiny little devices that have two distinct physical states, which we abstractly represent as 0 and 1. But actually, they could be, for example, magnets that are magnetized different ways. They could be electrical devices that are on or off. And the reason only two values are used, 0 and 1, instead of like 3 or 10 or some other number, is that we want it to be as reliable as possible. And it's most reliable to just try to distinguish two states, like on or off, or low voltage and high voltage, as opposed to low, medium, and high, or something like that. So just two states is a good choice, and that's what computer manufacturers have gone with. Now, there's billions of bits hanging around in your computer, and it would be too inefficient for the computer to move those bits one by one. So what it does instead is group them into chunks and moves a whole chunk around the computer, from the disk to the memory, from the memory to the processing unit, as a group. Now, the bigger of a chunk that the computer moves at once, potentially the faster it can be. So a 32-bit computer moves bits in 32 chunks of 32. A 64-bit would move them in chunks of 64. So right now, while I'm making this video, a 64-bit computer is a pretty cool computer. The original size of these chunks was 8 bits. And so that has a special name called a byte, back in the primitive days of computing. And things are still represented like gigabytes of memory, for example, because the numbers are smaller. They're easier to get your head around than if we would express it as a number of bits, and it's just traditional. Okay, now the most important program on your computer is the operating system. And this would be something like Mac OS or Windows or Linux or Unix. Those are the most common ones. And in fact, it's so important you sometimes say, like, I have a Windows computer, or I have a Mac, or I have a Linux computer, instead of giving the brand name, because it expresses the most fundamental thing about how your computer works. Now, what the operating system is in charge of is stuff like when you move your mouse around the screen and click on a window, that window activates. Your operating system is figuring out, well, what's on that piece of screen, and where's the mouse, and which program should I activate, and how should it change the screen so it looks active. And then when you type, the operating system makes sure that the characters you're inputting go into the active program and not some other program. So it's like organizing everything that's happening on your computer. To make the computer fast enough, the operating system has to reside in the working memory. But when you turn the computer off, that memory disappears. It's wiped out. So then when you turn the computer back on, there's no operating system. So how does it get going? Good question. Well, this is called booting, from the saying of picking yourself up by your own bootstraps. Typically, your computer has a special chip that retains its data when the power is off. And that chip has a tiny program built in. When you turn on your computer, that chip goes to work, and its whole job is to load the actual operating system into the memory. So when you first turn your computer on, you have to sit there for a minute or two while things happen. What's happening is the operating system is booting. It's being loaded into memory. Okay, now besides your operating system and some of the programs associated with it, what most people really are interested in is the application programs. And those are the things you use, like your browser, like your word processor, like your spreadsheet. your games, your music player, whatever. They are the ones that let you do what you want to do. The typical computer user just uses the applications. Now what we're going to look at is how to build some applications. Using Excel, we'll actually build our own little applications and give you a feeling for what it's like to actually produce computer software.